Welcome to Math with Mrs. Bibb. We are doing week 25 with Algebra 1 Honors. Please make sure to fill in your table of contents. I left a note here to remind myself that you need a sheet of paper and student journal page 237 for these notes. So if you want to pause the video and go get that, I completely understand. We are going to go straight to factoring completely. These first problems you're just going to do on a sheet of paper, so if you'll please get your sheet of paper and we'll look at these problems. We have not factored anything like number 1 and number 2 at all yet, or so it seems. You actually have been factoring 4 terms. We have been factoring trinomials by turning them into 4 terms and then factoring by grouping. So anytime you see 4 or more terms, you're going to use grouping to factor. Let's get started. So for question 1, we are going to group together. Hold on. We're going to group together the first 2 terms and the last 2 terms and make sure to put a plus sign in the middle. We're going to look at each group and look for the common factor. This first group, looking at 3xy minus 6x. They have 3, both of these are divisible by 3, x in common. We'll divide both of these by 3x. 3xy divided by 3x is y. Negative 6x divided by 3x is negative 2. This next group is a little strange. Do they have a common factor? Y and 2. They both don't have y, have a coefficient of 1 and a constant of 2. So the greatest common factor is 1, and we should write that. The greatest common factor is 1, so I'm going to put plus 1. I don't normally put the 1 out there, but it's very important for our answer to be able to have that plus 1. And then I will put y minus 2 here in parentheses. Okay, then let's look at the problem. Did it work? Did this work out for me the way I wanted it to? Yes. I have the same binomial here and here. Okay, so then, since I have the same binomial, I'm ready to factor into 2 separate binomials. Put what they have the same inside the first pair of parentheses, get rid of it, and then put what's left inside the second pair of parentheses. So y minus 2 times 3x plus 1 is the answer here. Okay, moving on to number 2. I have 4 terms, so I'm going to group the first 2 terms together, put a plus sign, and group the last 2 terms together. Next, we'll look for the greatest common factor in each group. In my first group, it looks like 4b is my greatest common factor. So we'll divide both of these by 4b, and they would have 3a minus c as what's left in the parentheses. And then in my second group, negative, because that first number is negative, 5c is my common factor. And you can write it either way, the division, either way, that's perfectly fine. You know you have to divide both of them by that number. Negative 15ac divided by negative 5 is 3a. Oh, I didn't write down my c. 3a is correct. And 5c squared divided by negative 5c is negative c. Did it work? It sure did. This binomial and this binomial are the same. So I'm going to have 3a minus c times 4b minus 5c. Remember, this goes away after you write it down, and what's left is what goes in the parentheses. And I left off that c, but I saw it. Moving on to the next problem. 25y cubed plus 5y squared plus 30y plus 6. So we're going to group the first two together because there's 4 or more terms. Put a plus sign in the middle. We're going to look at the first group. They have a common factor of 5y to the second power. I'm going to divide each of these by 5y to the second. 25y to the third divided by 5y to the second is 5y. 5y to the second divided by 5y to the second is positive 1. My second group has 6 in common, positive 6. I'll divide both of these by positive 6. 30y divided by positive 6 is 5y. 6 divided by 6 is 1. Did it work? Yes, it did. This term and this term are the same. So 5y plus 1 times 5y squared plus 6 is my answer. Next, I do notice when I look at number 4, and I did not mention it on 1, 2, and 3, but if you look at number 4, aren't all of these divisible by 2? So you should take out your greatest common factor first. That's what I'm going to do. I'm going to take out 2. I'm going to divide all of these by 2. And I'll have 6x to the third plus 2x to the second minus 15x minus 5. Now here's what I'm going to do. I'm going to bring this 2 down here and put it with my answer. That way it'll make it easier for me to just work the problem without the 2. I'm going to group the first 2 terms together. I'm going to put a plus sign, group the second 2 terms together. My first group has 2x squared in common. I'm going to divide each term by 2x squared. 6x cubed divided by 2x squared is 3x. 2 divided by 2 is positive 1. X squared divided by x cancels out. My next group, that first term is a negative, so I'm going to put a negative sign. 15 and 5 have 5 in common. I'm going to divide both of these by 5. Negative 15x divided by negative 5 is positive 3x. Negative 5 divided by negative 5 is positive 1. Then I'm going to write down what they have in common. That's 3x plus 1. I'm going to get rid of what they have in common, and that's 2x squared minus 5. Moving on to number 5. I'm going to look at both 5 and 6, and neither one of them all have a common factor, all 4 terms. I'm going to group the first 2 together, group the last 2 together, and then I'm going to take out the greatest common factor. I believe what I'm going to do as I'm writing this down is I'm going to stop the video. I'm going to do the problems, and then you pause. You can pause now or while I'm talking, or when I'm finished talking. I'm going to work both of these problems, and then I'll turn the video back on so you can check your answers. Because you've heard me talk through 4 examples of factoring by grouping. This way it'll save you some time. So pause the video, do these 2 problems, and then you can fast forward to check to see if you got them right. Now if you want to quickly check to make sure you got the right answers, then once you know you have the right answers, you're welcome to fast forward. I'm just going to quickly go through and discuss this. The only difference I see in these problems would be from number 6. And here my greatest common factor included an x and a y. Let's talk about y really quickly. X squared and x would be the common factor. Y and y squared, y would be the common factor. And of course 15 and 10, I know you all know. that 5 is the greatest common factor. So I did have two variables here and divided both of them. And I hope that you got these answers correct. And if you have any questions, please feel free to reach out and ask. I'm happy to help. Moving right along to the next page. Let's do the same thing here. Why don't you write down those two problems, work them out. I'm going to pause the video after I stop talking, and I'm going to work them out, and then I'll start the video again. I started the video again because as I grouped the first two together and the last two together, I noticed that really for the first group, they don't have a common factor. The second group does, but the first group does not have a common factor. This is one of those circumstances where you need to regroup. And you can choose how you want to regroup. You can put 16 and 4 together and 5 and 20 together. It's completely up to you. I think that I will put my 16 and my 4 together, and I'm going to put my negative 5xp and my negative 20xc together. Now I'll pause and continue the problem. Okay, so I completed number 7, and I did run into a little bit of a snag here. It appeared that this binomial and this binomial may not be the same, but if you realize that addition is commutative, then 4z plus p is the same thing as p plus 4z. So this should be close to the answer that you have. I believe we're going to run into the same thing with number 8. If we group the first two and group the last two, we're not going to get a binomial that's the same. So I believe I'm going to group this one with this one. We'll see if it works. I may have to regroup again. Sometimes you have to. And then I'm going to group this one with this one and see how that goes. So if you'll pause and then do your problem, and then we'll see how that problem works out. Okay, so that did work for me. I grouped the green ones together and the red ones together. I did choose, that's why you see two answers here. I did choose to think about this one as 3y plus 4x. I bet the textbook would have thought about this as 4x plus 3y, just to put these in alphabetical order. But honestly, either answer is correct. If you have 3y plus 4x or 4x plus 3y, that's perfectly fine. Either answer is okay. So hopefully you got those and you did okay on them. Let's move on to the next problems. So if you will pause the video and write this at the bottom of page 237, Student Journal page 237. This is still page 99 in your notebook. We're going to do a pattern called difference of squares. We're not going to be doing 7 through 12 at the bottom, so it's okay if you just scribble those out and write this in. So pause the video and write this down, please. Here are our questions that we're going to do on this page. And when we look at this, you do want to look at every problem. Look at this one and this one. You want to look for a greatest common factor. But I do not believe that any of those have a common factor. It does happen sometimes that you'll have one, but I don't think any of those do. So here we have a binomial. We have not factored binomials except having a greatest common factor. So that's going to change today. Now when I look at all those, I don't have a greatest common factor, so I can't say it's not going to factor. I have to check for a difference of squares. Difference in mathematics means you have a subtraction problem, and squares means you've got perfect squares that you're looking at. So if you look at every one of these, s to the second is a perfect square because s times s is x squared. 49 is a perfect square because 7 times 7 is 49. T times t, 9 times 9, 4 times 4, x times x, 2g times 2g, 5 times 5, 6h times 6h, 11 times 11, 9 times 9, 7k times 7k. And every single one of these is a subtraction problem. Now I will tell you, in the set of real numbers, if any of these were addition problems, then you would not be able to factor these over the set of real numbers. But they are all subtraction problems, so the first thing that I can do And I want you to get this in your mind. The first thing that you do is you put 2 and leave space because we'll do some writing. Put 2 empty binomials, one with an addition sign, one with a subtraction sign. Every single problem, 2 empty binomials, one with an addition sign, one with a subtraction sign. Again, I like to say it over and over so it'll drill it into your brain. 2 empty binomials, one with a plus sign, one with a minus sign. And again, and again, and one more time. Hope I left myself room to write. I hope you left yourself room to write. Then, this is the work that I expect to see. You're going to take the square root of s squared. You're going to put that answer in the first spot of each binomial. Then you're going to take the square root of 49. You're going to put that answer in the second spot of each binomial, and you're done. That's the answer. For the next problem, I'm going to take the square root of t squared. That answer goes in the first spot of each binomial. Then take the square root of 81. That answer goes in the second spot of each binomial. I want to point out that you do not include the negative when you're taking the square root. This negative just indicates that you have a difference of squares. Then you're going to take the square root of each separate number without that negative sign. You're going to take the square root separately without the negative sign. For the next one, the square root of 16 is 4. The square root of x squared is x. The next one, the square root of 4g squared is 2g. The square root of 25 is 5. And all of these are finished. I didn't circle them. Factoring a sum and difference of squares is easy if you can remember this pattern. Students who say that they don't understand just do not realize it is just simply a pattern that you have to be able to recognize. So I'm going to take the square root of 36h squared. That's 6h. That goes in the first spot of each of those. I'm going to take the square root of 121. That goes in the first spot of, the second spot of each binomial. And then the last one, the square root of 81, is 9. That goes in the first spot of each of these. And the square root of negative, see, look, I did what I told you not to do. We'll take the square root of 49, k squared, and that is 7k. That goes in the second spot. And that's my answer. So hopefully you can look at and recognize that pattern. You may run into some that have a common factor. For example, 2x squared minus 50. I would take out my greatest common factor of 2, and I would have x squared minus 25. Before we did this lesson, you would have stopped there because that would be all you know to do. But now we know we have a difference of 2 perfect squares. So we should carry on and have the answer 2 times 2 empty binomials, one with a plus sign, one with a minus sign. Take the square root of x squared. X goes in the first spot of each of those. Take the square root of 25. 5 goes in the second spot of each of those. So this is my answer to my extra example that I gave. I hope you have a wonderful day. Thank you for listening.